Okay, so tonight we're going to talk about resonance. Okay, so let me just now. So as an introduction for the resonance, so when the voltage V applied to an electrical network containing resistance, inductance, and capacitance is in phase with the resulting current I, so the circuit is said to be resonant. Uh, so sinasabi rito no in phase. So in phase. So yung kanyang phase difference is zero, okay? Or is equal to ang ating power factor niya na would be equal to 1. So the circuit is said to be in resonance. So the phenomenon of resonance is of great value in all branches of radio, television, and communications engineering since it enables small portions of the communications frequency spectrum to be selected for amplification independently of the remainder. So what does this mean? So the resonance is very important. Okay, especially especially uh, uh, in our sector, no, in our field. Okay? So so at resonance, so the equivalent network impedance Z, okay, is purely resistive since the supply voltage and current are in phase. So yung mawawalan tayo ng so XL and XC and XL is not okay, is not existing. Okay? So, and then for the power factor of a resonant network, it is equal to unity. Okay. So last meeting we have already discussed so what is the main function of a power factor, di ba? So in electrical work there are two types of resonance. So one is associated with series circuits, that is when the input impedance is at minimum, and the other one is associated with simple parallel networks, and that is when your impedance is at maximum. Okay? So you better you have to remember that now. So we now have an RLC series circuit here where our XL is equal to XC. Okay. So at resonance, your XL is equal to XC. Okay. So the applied voltage V and the current I are in phase. So this effect is called series resonance. Okay. Well, at series resonance, our the voltage across the inductor is equal to the voltage across the capacitor. Okay? So, ito yung circuit natin for a series, okay? For a series resonance, wherein VL is equal to VC, okay? And then your impedance Z, okay, is equal to the resistance R, and that is the minimum circuit impedance possible in an LCR circuit or RLC circuit. So however uh, you put the first uh, component, okay, of the circuit, and the third, okay, so for series resonance, to determine the current I, we could make use of the V over R equation, and that is for the maximum current possible in an LCR circuit. Okay, and then since XL is equal to XC, then the 2 pi FRL. Okay, so the FR now corresponds to the resonant frequency. Okay, so this is the resonant frequency, and the resonant frequency now, so that is 2 pi FL, ito yung XL natin. Okay? And this is our XC. 1 over 2 pi FRC. So from which our resonant frequency now would be equal to 1 all over 2 pi the square root of the product of L and C. Okay? The product of the inductance and capacitance. Okay? Baka hindi nyo na nakikita yun sa ilalim. No? The resonant frequency FR, okay, is equal to 1 all over 2 pi, okay, multiplied by the square root of the product of L and C. So since this is frequency, then it is measured in hertz. Okay? Now, the series resonant circuit is often described as an acceptor circuit since it has a minimum impedance. Okay? So kaya siya acceptor, okay, dahil yung kanyang impedance ay minimum. So ibig sabihin yung kanyang ohmic resistance is very low, kaya yung current, okay, your current now will tend to be high. Okay? So, typical graphs of current I and impedance Z against frequency are shown in our figure here. So, this is our circuit, series RLC. So, R is our resistance, L is for our inductor, and C is for our capacitance. And across R, okay, we could measure the voltage across R, okay, and also we could measure the voltage across, okay, the inductance, and also we could measure here, so what we are measuring here is the voltage across our capacitor, and the and the and the components are connected with our V, okay, with our voltage V. So ganito yung current direction niya. So this is our I actually. Okay? So here, makikita nyo rito, di ba? This is now the impedance Z and the current I. So this will now be our impedance Z. So makikita natin dito na uh, as the resistance, okay, as the resistance increases, makikita natin yung I natin is somewhere is also increasing. So yung ating Z, okay, this is our impedance Z, which is what you call this, uniformly, okay, uniformly increasing, while our XC and XL are exponentially, okay, exponentially increasing. And so ito yung ating XC, no, nasa ilalim. So this will now be, so there will be a point in our XL and our XC na magkakaparehas na sila. Okay? So pagkaparehas na yung XL at XC natin, if this is our frequency, itong x-axis, okay? So kung saan maging equal yung ating XL at yung ating XC, that is now our resonant frequency. Okay? So let's have an example so that we could understand this. So we have a problem, a coil having a resistance of 10 ohms and an inductance of 125 millihenry is connected in series with a 60 microfarad capacitor across a 120 volt supply. So at what frequency does resonance occur? And then find the current flowing at the resonant frequency. So we have a series resonance, no? So let's say this is our voltage V, and then we have an R, okay, an L, and a C connected in series. Okay. So this is 120 volts. So our resistance R, okay, so this is our R, L, and C. So our R is 10 ohms. Our L is 125 millihenry. Okay. And our capacitor is around 60 microfarad. Okay. Now, what we need to find is what would be the frequency wherein the circuit will be at resonant, okay, or at resonance, okay. So we are given by the equation, okay, the resonant frequency is equal to 1 all over 2 pi multiplied by the square root of the product of the inductance and capacitance. So the resonant frequency, so we have, let's see our ingredients, okay. So ito yung ating equation. So we have an L which is equal to 125 millihenry, and so we also have C or capacitance which is equal to 60 microfarad. So in this case, we could now determine the resonant frequency dahil all of our ingredients are complete. While 2 pi naman is a constant, so therefore we could now simply substitute the values of the inductance and capacitance. So let's make use of the equation that is 1 all over 2 pi square root of MC. So 1 all over, okay, so we have the 2 pi as our constant, and then the square root of L is equal to 125 millihenry. So this is also the same as 125 times 10 to the negative 3 multiplied by 60 microfarad. So this is also the same as 60 times 10 to the negative 6. Okay. And then we just multiply them, take the square root, multiply it by 2 pi, and then get the inverse. And now we will now have a value of 58.12 hertz. So ibig sabihin, okay, doon sa ating graph, okay? So this is our XL and then this is our XC. Okay? So there will come a time, okay, and this is our frequency. So there is some at 58.12, okay, at 58.12 hertz, okay. So this is our XC, this is our XL, this is our XC. So there will have, so at this point and at this point, okay, the frequency is at resonance. So well, so we could check, okay, okay, we, actually we could check the XL if that is equal to XC later, okay. So at resonance, your XL is equal to XC and your impedance Z is equal to simply your R, okay. So hence, okay, so we could now find the current because of these conditions. So to find the current, so we could make use of Ohm's law. So that is I is equal to the voltage divided by resistance R. We already have a supply voltage equal to 120 volts, and we have a resistance R. Okay, we have a resistance R equal to 10 ohms. So that is 120 divided by 10, and the current of the circuit now would be equal to 12 amperes. Okay. Okay. So let's have another example. So the current at resonance in a series LRC circuit is 100 microamp. Okay. So if the applied voltage is 2 millivolts at a frequency of 200, okay, 200 kilohertz, and the circuit inductance is 50 microhenry, we are to find now the circuit resistance and the circuit capacitance. So what are now, so let's see, so what are our given, okay? So we have, okay, so we have a current, okay? We have a current equal to 100 microamp. So this is also equal to 100 times 10 to the negative 6, okay, ampere. And then we also have a voltage V equal to 2 millivolts. Okay, so that is also equal to 2 times 10 to the negative 3 volts. Okay. And then we have a frequency equal to 200 kilohertz. So that is 200 kilohertz. Okay, so that is also equal to 200 times 10 to the 3 hertz. Okay. And the circuit inductance L is equal to 50 microhenry. Okay. And that is also equal to 50 times 10 to the, what is micro? 10 to the negative 6. Okay. Henry. Okay. So let us now find the circuit resistance. For the circuit resistance, we could make use of the Ohm's law, wherein the resistance is equal to V over I. Okay. So remember that at resonance, your impedance Z is equal to your resistance R. Okay. So we could now have V over I. So tingnan natin, meron ba tayong V? So meron tayong V, meron tayong I. So kompleto yung ating ingredients. So let's just substitute. So our V is 20. Oops, let me see. Okay, so this is just 2 millivolts. Okay. So 2 times 10 to the negative 3 divided by, okay, so divided by our current, which is 100 times 10 to the negative 6. Okay. So it is equal now to 20 ohms. So at resonance, your XL is always equal to XC. So ito yung XL natin, ito yung XC. Okay? So pwede natin gamitin kahit alin dito sa dalawa. Okay? Or we just equate these two to find C. Di ba? So if we are going to equate them, we could now determine C. So that means that ha? Excuse me. Okay, so that will now be 2 pi f square. Diba? 2 pi f to, tsaka 2 pi f yun. Multiplied by L. Okay? And that is 1 all over C. Okay? So, therefore, your C now would be equal to 1 all over 2 pi f square L. Okay? So, ito siya. So, meron tayong frequency, meron tayong L, so we can now determine C. Okay, so that will now be 1 all over 2 pi multiplied by the frequency of 200 times 10 to the 3. Okay, so ito yung ating frequency. And this is now our L, which is equal to 50 times 10 to the negative 6 Henry. Okay, so if we do that with our calculator, baka hindi nyo na nakikita yung nasa ilalim. So that is equal to 0.0127 microfarad. Okay? Or so that will now be, we move another 3 places to the right. So that is 12.7 nanofarad. Okay? So this will now be equal to 12.7 times 10 to the negative 9. Okay? Farad. Okay? So that will now be our final answer. Okay? So let's talk about now Q factor. So what is now the Q factor? Okay, so at resonance, if R is small compared with XL and XC, so nakita natin dyan, no? So if R is small, so compared with XL and XC, it is possible for VL and VC to have voltages many times greater than the supply voltage. Okay? And that is what we call the voltage magnification at resonance. Okay, na ma-magnify, okay? Na dodoble-doble, okay? Yung ating voltages, yung ating voltages across the either sa inductor or sa capacitor many times greater than the supply voltage. Okay? And the voltage magnification at resonance can be determined by the ratio of the voltage across L or C divided by the supply voltage. Okay? So this ratio is a measure of the quality of a circuit. Okay? Lalo na at a resonator or a tuning device. Okay? So the measure of the the quality, okay, of a tuning device is what we call the Q factor. Okay? So the Q factor now can be determined. Puntahan na natin yung dulo, no? So the Q factor, okay? So the Q factor can be determined by the equation of 1 all over R multiplied by L over C. Okay? 1 over R multiplied by the square root of L over C. And that is how you determine the Q factor. Okay? So let's have this our example. So a coil of inductance of 80 millihenry and negligible resistance is connected in series with a capacitance of 0.25 microfarad and a resistor of resistance of 12.5 ohms across a 100 volts, okay, variable frequency supply. So we are now to determine the resonant frequency. Variable yung ating frequency. Okay, so we are to determine the resonant frequency and the current at resonance. So how many times greater than the supply voltage is the voltage across the reactances at resonance? Okay, so first, let's talk about, so let us, so let's determine first the resonant frequency. So the resonant frequency is equal to, again, our resonant frequency is equal to 1 all over 2 pi multiplied by the square root of L and C. So kita naman natin sa ating problem statement that we have an L of 80 millihenry and a capacitor of and a capacitance equal to 0.25 microfarad. So we could now determine the resonant frequency. Okay, so let's substitute the values of inductance and capacitance. So that is equal to 1 all over 2 pi, okay, multiplied by the square root of 80. So pwede rin naman yan na 80 times 10 to the negative 3, okay, multiplied by 0.25 times 10 to the negative 6. So our resonant frequency would be equal to 1.1254 kilohertz. Okay. So we could now also determine the current I. So yun yung hinahanap sa ating letter B. So the current at resonance. Okay, so that will now be equal to 100 over 12.5. Okay, so meron kasi given naman yung voltage at given din yung R natin. Di ba? Ito, so 12.5 across a 110 volts. So we just simply divide 100 by 12.5 and that is equal to 8 amperes. Okay? So the voltage across inductance at resonance, so that is VL. Okay? So VL now would be equal to IXL. Okay? So remember that this is ampere and this is resistance. Okay? And measured in ohms and this is V. So by Ohm's law, okay, so the voltage can we could determine the voltage by the product of the current and the resistance R. So here, so since we are talking about AC, so it would be the inductive reactance multiplied by the current to get the or to determine now the voltage across the inductor. And that is I multiplied by 2 pi FL. Okay, so we have a frequency coming from here, our resonant frequency. Okay, and that is uh, 1.1254 kilohertz. Okay, or that is 1125.4 hertz. Okay, so let's substitute for the I. We have 8 amps, constant of 2 pi, frequency of 1125.4, and an inductance of 80 millihenry coming from here. Okay, coming from here. Okay. So the voltage across the inductor now would be equal to 4525.5 volts. Okay. So we could also determine VC, okay, or the voltage across the capacitor by using the formula current multiplied by the capacitive reactance. So capacitive reactance is given by 2 pi FC, 1 all over 2 pi FC actually. And that is multiplied by current, so that is current over 2 pi FC. Okay, we have current of 8 amps. This is constant. We have a frequency of 1125.4 and we have a capacitance of equal to 0.25 microfarad. Okay, and then substituting them, we could now determine the voltage across the capacitor, which is equal to 4525.5. Okay, 4525.5 volts. Okay. So, makikita nyo, di ba, parehas yung BL at saka yung ating PC. Okay? So, that means na nasatisfy natin yung okay, this one. VL over VL is equal to VC. Okay? Now, to determine now the magnification, the voltage magnification, so we could make use of the voltage across L or we could make use the voltage across C. Okay? And then we divide it by the supply voltage. So, to get the voltage magnification ratio, again, ito, no? We could make use of VL or we could make use of VC and divide it with the supply voltage P. Okay? So, and that is, we have 4525.5 divided by 100. So, we have 45.255 volts. Okay? So, that is now the voltage magnification at resonance. So, that only means that the voltage across the reactances are 45.255 times greater than the supply voltage. Okay? So, hence, the Q factor now of the circuit would be equal to 45.255. Okay. So this is now our Q factor. Okay. Okay. Can you follow? Can you still follow?
Yes, sir.
Okay. So very good. Okay. So let's have another example. Okay. Ulit na. So next example. So a series circuit comprises a coil of resistance 2 ohms, an inductance of 60 millihenry, and a 30 microfarad capacitor. We are now to determine the Q factor of the circuit. Okay, so meron daw tayong series, okay, series circuit that comprises a resistance, a coil, okay, and a capacitance or capacitor, okay. So this is our R, this is our L, and this is our C. And we have here 2 ohms, and then L is equal to 60 millihenry, and our C is equal to 30 microfarad. Okay, and we are to determine the Q factor. So we all know now that the Q factor is equal to 1 all over R multiplied by the square root of the quotient of L and C. Okay, so from the given, we have R, we have L, and then we have C. Okay, yung 1 naman ay constant. So our ingredients are complete. So therefore, we could now determine the Q factor of the circuit. Okay, so we have 1 all over R, so that is 1 all over 2 multiplied by the square root of L, which is equal to 60 times 10 to the negative 3 Henry. And our capacitance is equal to 30 times 10 to the negative 6 Farad. Okay? So we could now make use of our calculator. So therefore, our Q factor now would be equal to 22.36. Okay? Okay. So let's continue with another example. Okay, so another example here. So we have a coil of negligible resistance. So pagka sinabi negligible resistance, your R is equal to 0 na, no? The negligible resistance na. And inductance of 100 millihenry is connected in series with a capacitance of 2 microfarad and a resistance of 10 ohms across a 50 volts variable frequency supply. So we are now to determine the resonant frequency and then the current at resonance, and letter C. So we have the voltages across the coil and the capacitor at resonance, and D. So we are to look for, okay, or to compute for the Q factor of the circuit. Okay. So we have, so what are our given? So we have an inductance I is equal to 100 millihenry. And then we have a capacitance equal to 2 microfarad. And then we have an R is equal to 10 ohms across a voltage equal to 50 volts. Okay. Now, so we could now determine now the resonant frequency. So resonant frequency is 1 all over 2 pi multiplied by the square root of L and C. So meron tayong L. Sorry, this is L, not I. Okay. So we have L, we have C. So that is 1 all over 2 pi times the square root of 100. Okay, so 100 equal dito sa 100 times 10 to the negative 3. Okay, times the capacitance of 2 times 10 to the negative 6. Okay, and our resonant frequency now would be equal to 355. Okay, 355.9 hertz. Okay, so we could now determine the current. Okay, so litaw ko lang dito kasi nasa ilalim siya. Okay, bakit hindi nyo nakikita? So your current now would be equal to V over R, and that is 50 from our problem statement. So divided by R, which is 10. So our current now would be equal to 5 amperes. Okay? Dahil kompleto na ang ating mga ingredients, we could now determine now the voltage across the coil. So this is the voltage across the coil. So that is equal to the product of the current multiplied by the inductive reactance. So we have I, that inductive reactance now, ito yun, ano? That is 2 pi FRL. So we have a current of 5 multiplied by 2 pi times 355.9. Ito yung ating resonant frequency coming from here. Okay? Multiplied by our inductance of 100 times 10 to the negative 3 Henry. So the voltage across the coil is equal to 1118 volts. Okay. So let's see if we could satisfy the VL is equal to VC on series resonance. Okay. So by determining the voltage across the capacitor, which is given by current multiplied by the capacitive reactance. So capacitive reactance, so ganito yan, ano? So that I times 1 all over 2 pi FC. Okay? So that is I multiplied by 1 is I, okay, over 2 pi FC. Okay? So kompleto yung ating ingredients. So we could just simply substitute the value of the current, which is equal to 5 amps. So our constant 2 pi, our resonant frequency of 355.9 hertz, and the value of our capacitance, which is equal to 2 times 10 to the negative 6 farad. So therefore, we could also check that the voltage across the capacitor is equal to 1,118 1,118 volts. Okay, sorry. Okay. So makikita natin na parehas yung okay, the VL is equal to VC, which satisfies okay, yung conditions natin at series resonance. Okay? Now, to get the Q factor or the voltage magnification at resonance, we could make use of VL or VC and then divide it by the supply voltage V. Okay? So, VL now would be equal to 1,118 divided by 50 and the Q factor now would be equal to 22.36. 22.36. So, that is our Q factor. So, everything in the problem statement has been satisfied. We have determined the resonant frequency FR, which is equal to 355.9 hertz. We have also satisfied the current at resonance, which is equal to 5 amps. Okay. And the voltage across the coil and the capacitor, which is equal to 1,118 volts. Okay, so okay na rin yan. And also the Q factor, which is equal to 22.36. Okay? So that's it for the series resonance. So let's talk about now the parallel resonance. Okay? So meron tayong series resonance. So therefore, meron din naman tayong parallel resonance. Okay? So that is your resonance occurs in two branch network containing capacitance C in parallel with the inductance R. Inductance L and resistance R in series. So we could have it, okay? So C in parallel with the inductance. Okay, so for example, we have okay, our voltage V. Oops, sorry. Okay. And L and C are in series. L and R are in series. Okay. And then C is in parallel. Okay. So, ganito yung ating circuit. Okay. And this is now, this can now be represented by the graph. Okay, so the vertical is our IC or the current flowing through our capacitor, and we have ILR. Okay, so ito yun. So this is ILR or the current flowing to the through the resistance and the coil, and this is our IC. Okay. So we could see that this is the resulting, okay? So this is the resulting ILR, okay? And this will now be our voltage V. So the ratio between them, so this height, okay? So this magnitude here is equal to your ILR sine phi sub 2, okay? Or sorry, sine phi sub 1, okay? So that is when the quadrature component of ILR is equal to IC. Ito, no? Your IC is equal to your ILR. Okay? So, they will now be in resonant. Parallel nga lang, okay? And in parallel resonance, okay? Okay? In parallel resonance, okay? Your we could determine the resonant frequency by this equation. We have 1 all over 2 pi multiplied by 1 all over LC minus R square over L square. And it is again measured in hertz. Okay? But when R is negligible, so pagka sinabi natin negligible, that is almost zero, then the resonant frequency would be equal to 1 all over 2 pi multiplied by the product of L and C and taking the square root. Okay? So, mapapansin nyo na kapag ka ang R ay negligible in a parallel resonance, it is also equal to the series resonance. Okay? Because R would be 0. Diba? Kasi pagka ito naging 0, diba? Wala na tong value na to actually sa series. I mean sa parallel resonance. And ang matitira na lang is 1 all over 2 pi times the square root of 1 all over LC. Ito rin yun. Okay? And to determine the current at resonance, okay, so we could make so the current at resonance would be equal to the product of VRC divided by the inductance L. Okay. And for the dynamic resistance, okay, so dynamic resistance is the current at resonance is in phase with the voltage. So the impedance of the circuit acts as a resistance. Okay. So this resistance is known as the dynamic resistance, or sometimes called the dynamic impedance. Okay? And it can be determined by pwedeng V over IR. Okay? Pwede rin naman V over VRC over L. Okay? Kasi di ba yung IR natin is equal to this one, VRC over L. Okay? And we could also determine the dynamic resistance by L over the product of RC. Okay? So, but, yeah. Finally, we could now have or make use of this equation. Okay? Pero pagka tawag dito, so magagamit natin to, no, kung there is something missing in the equation to satisfy this one, no? L over RC. Okay. So this is a comparison between the series and the parallel resonance. So this is our series resonance and this is now our parallel resonance. So makikita nyo mag-inverted sila. No? So for the series resonance, so mapapansin nyo na nandito sa area na to yung kanyang minimum yung kanyang R. Okay? And while here, naka-maximum yung kanyang R. Okay? Tapos nandoon yung resonant frequency and somewhere here din yung kanyang resonant frequency. Okay? So, if the series resonance is connoted, okay? Connoted as acceptor, yung parallel resonance natin naman is noted naman siya as rejector circuit. Why? So because in parallel resonance, it's often as it is often described as a rejector circuit since it presents its maximum impedance at the resonant frequency. Okay? So, sobrang taas nung kanyang resonant frequency. Kaya, ito, mapapansin nyo, nasa taas yung impedance. Okay? So, mechanical analogy. So, electrical resonance for the parallel circuit can be likened to a mass hanging on a spring, which, if pulled down and released, okay, will oscillate up and down, but due to friction, the oscillations will slowly die. So, dito, nagawa na natin to experiment na to doon sa ating physics. Okay? Pagka hinila na, you have a weight, okay, connected to a spring, and then you try to stretch downward the spring, and then you let it go. When you let it go, so mag-up and down yung ating spring. Now, hanggang sa unti-unti na siyang tumigil. Okay? So, to maintain the oscillation, the mass would require a small force applied each time it reaches its point of maximum travel. And this is exactly what happens with the electrical circuit. Okay? With a small current is required to overcome the losses and maintain the oscillations of the current. Okay? So when we say oscillations, that is the variation, no? So variations of the current. Okay? So parallel resonance application. So one use of for resonance is to establish a condition of stable frequency in circuits designed to produce AC signals. So saan-saan kaya 'yun, 'di ba? So mostly tawag dito ginagamit natin tong tawag dito yung uh, constant AC signal when we are transmitting signals, analog signals uh, across the air, okay, or any medium actually. Okay, so usually a parallel circuit is used for this purpose. So with capacitor and inductor directly connected together, exchanging energy between each other. Okay? So nakagang yan. No? So when you say gang, they are paired. Okay? So the inductor and the capacitor are paired together. So just as a pendulum can be used to stabilize the frequency of a clock mechanism oscillations, okay? So can a parallel circuit can be used to stabilize the electrical frequency of an AC oscillator circuit. So when we say oscillator circuit, this is the one that gives timing, no? Timing doon sa pag-release or pag-send ng signal through the circuit. So another use for the resonance is in applications where the effects of greatly increase or decrease impedance at a particular frequency is desired. So if we want to lower down or if we want to lower the frequency, okay, or the impedance, so we could make use of a parallel resonance. Or likewise, if we want to increase, the impedance of the circuit, then we could make use of a parallel resonance. Okay. So another application of resonance, okay, so a resonance circuit can be used to block, okay, present high impedance toward a frequency or range of frequencies, thus acting as a sort of frequency filter to strain certain frequency out of a mix of others. Actually, this is an example of this is a dividing network that is used in what they call this audio setup, wherein the frequencies are divided to high, and then we have the medium, and also we have the low frequencies. So high, this is ito na, kung mahilig kayo sa sound system, okay, itong high, ito yung mga kalansing, okay, yung mga sagit-sit na naririnig natin sa sound system. And then medium, this is the vocals, and then the low frequency corresponds to the bass. Okay, so we could make use of parallel resonance or the divided network. This is the very old term, yung divided network. So the other term for a dividing network is crossover. Yeah. Whether it is a passive crossover or it is an active crossover. Okay? Yeah. So we have a frequency, multiple frequency as our input. Okay? So this is our input. Yan, yan yung ating no? Ay dito, frequency. Halo-halo yan. No? So pagka yan dumaan ng crossover, we could divide, okay? We could filter, okay? We could filter the this combined frequency into high frequency, okay? Ayan, mga high frequency, and then we could for the high, and then we could now have the medium frequency, and then we could now have the low frequency. Okay? So this is our input, okay? And this will now be our output. Okay? So filter yan, no? This is what we call high pass, okay? And this is what we call the lower, so this is our low pass. Okay? So actually this is low pass din, pwede natin tawagin low pass yung mid, and then VLP naman is the bass, very low, okay? Very low pass filters. So in fact, this particular circuits are filters. Okay, so in essence, this is how analog radio receiver tuner circuits work to filter or select one station frequency out of the mix of different radio station frequency signals intercepted by the antenna. So dito, ang pinag-uusapan natin, this is an analog radio. Okay, so for example, we have 96.3, okay, 96.3 megahertz. Okay, this corresponds to DW rock. Okay, and then we have 97.1. Okay, we have 97.1 is LSFM. Tama ba? LSFM. You know? So we just, di ba, itong lahat ng frequency nito or itong lahat ng radio stations that are broadcasting simultaneously, pwede mong mapakinggan yung kanilang mga binobroadcast in a single device or in a single radio. okay, having an antenna. So how? By varying, okay, varying the frequency. Okay? By varying the frequency of the circuit, okay, and tuning into the assigned frequency of the assigned frequency ng station or ng broadcasting station, ang nag-a-assign yan NTC or the National Telecommunication Company. Okay? National Telecommunication Commission, sorry. Hindi pala company, commission, sorry. Okay? So in essence, this is how analog radio receiver tuners work. So fini-filter pa rin. So there is a knob, okay? Yung mga sinaunang radio, so analog pa, so you could turn it clockwise or counterclockwise to deter to tune in, okay? To tune in to the desired frequency of the broadcasting station. Okay. So this is another applications of resonance. So naglalagay tayo ng resonance for oscillators that are already dying. Okay. So when you say dying, ito humihina na yung signal. Baka sa sobrang layo na hindi na kayang hindi na kayang i-pick up. Okay, hindi na kayang i-pick up ng antenna natin if we are talking about analog transmission, then we could from doon sa point na medyo na napipick up pa natin yung yung signal, then you could you could connect an oscillator circuit from there, receive the signal, and then rebroadcast it so that the oscillations can be maintained. Okay. So likewise with the series resonance, meron din Q factor ang parallel resonance. And the parallel resonance now can be determined by the equation of or by the ratio of XL and R. Okay? So in that case, di ba? So kung sinasabi natin the Q factor at resonance would be XL, would be the ratio between XL and R. So we could make use of this formula. So that is 2 pi FRL. So that corresponds to our XL divided by R. Okay. But note that in parallel circuit, the Q factor is a measure of current magnification. In series circuit, in series resonance, the Q factor there is voltage magnification. Okay. At parallel resonance, it is current magnification. Okay. So at mains frequency, the Q factor of a parallel circuit is usually low, so typically less than 10. But in radio frequency circuits, the Q factor can be very high. Okay. So let's have an example on parallel resonance. So that is a pure inductance of 150 millihenry is connected in parallel with a 40 microfarad capacitor across a 50 volt source and a variable frequency supply. So we are now to determine the resonant frequency of the circuit and the current circulating in the capacitor and inductor at resonance. Okay, so this is how our circuit. Okay, so we have a parallel LC, okay, connected to a 50 volt supply. Okay, so to get the parallel okay, to determine the resonant frequency of of the circuit. Okay, so parallel resonance is equal to 1 all over 2 pi multiplied by the square root of 1 over LC minus R square over L square. Okay, so however, okay, so sinabi dito na this is a pure inductance. Yeah, pure, so so walang binanggit dito na R, no? And makikita din naman natin sa circuit natin na wala itong R. So malamang sa malamang, the R here is negligible. Okay? So if the R is negligible, so this will not be existing, and therefore, okay, it will now just be equal to 1 1 all over 2 pi multiplied by the square root of 1 over LC. So, naging kaparehas na rin ito ng series resonance. Okay? So, substituting all the values for the L and C, so we could now determine our resonant frequency equal to 64.97 Hertz. Okay? And that we have already satisfied letter A, which is finding the resonant frequency of the circuit. So let's try to find now the current circulating in the capacitor and inductor. Okay. So to determine the current circulating in L and C at resonance, so we could make use of this. Okay. So the current is equal to V over XC. And so we could now have, so V over yung XC natin, ito yan, 1 all over 2 pi multiplied by the resonant frequency and capacitance. So when we evaluate this, so we could now have 2 pi FRCV. Okay? So hence, so meron tayong resonant frequency which is 64.97 Hertz. Meron tayong capacitance na 40 microfarad, and we also have a supply voltage of 50. So substituting all of this to the sa ating ingredients, so we could now determine the current, the current circulating in the circuit to be 0.816 amperes. Okay? So pansinin nyo, no? So kung ang gagamitin naman natin ay XL, okay? May konting-konti lang yung diferensya, okay? Which is 0.817 amps. Okay? Or that would be equal to 816 milliampere. So if gagamitin naman natin yung XL, so that will now be equal to 817 milliampere. Okay? So next, another example. So we have a coil of inductance of 0.20 Henry and resistance of 60 ohms is connected in parallel with a 20 microfarad capacitor across a 20 volt source with a variable frequency supply. So we are now to calculate the resonant frequency, the dynamic resistance, the current at resonance, and the circuit's Q factor at resonance. Okay? So at okay, parallel resonant frequency, okay, in a parallel circuit, so we have 1 all over 2 pi. Okay? 1 over 2 pi actually multiplied by the square root of 1 over LC minus R square over L square. Okay, so ngayon meron tayong R, no? So hindi negligible yung ating resistance. So we could just, so meron tayong R. And so we have L of 0.2 Henry. We have C of 2 microfarad. Ginawa natin. So we have L of 0.2 Henry. We have R, okay, of 60 ohms. And we have C of 20 microfarad. And we have V equal to 20 volts. Okay. So merong L, merong C, merong R. 2 pi is constant, 1 is constant. So therefore, we could now determine the resonant frequency, which is equal to 63.66 Hertz. Okay. Dynamic resistance is given by the equation, okay, L over RC. We have L, we have RC, so dynamic resistance would be equal to 166.7 ohms. And the current at resonance, okay, we have, okay, so we have voltage V, then the dynamic resistance of 166.7. So we could now have a current, okay, at resonance of 0.12 ampere, or that is 120 milliamp. Okay. And for the Q factor, okay, so that will now be equal to 2 pi FRL over R. Okay. So this is XL over R, di ba? XL over R. So we have 2 pi, we have FR of 63.66 hertz, and an L of 0.2. Okay. So the circuit's Q factor is equal to 1.33. Okay. So this is just an alternative way of determining the Q factor by using XC naman. Kasi dito dito, ginamit natin dito ay XL. Remember that at resonance, XL is equal to X. Okay? So another example, okay, so we have a coil of inductance 100 millihenry and a resistance of 800 ohms. Okay, is connected in parallel with a variable capacitor across a 12-volt source with 5 kilohertz supply. 12 volts, 5 kilohertz. Okay. So determine for the condition when the supply current is minimum, and so the capacitance of the capacitor, the dynamic resistance, and the supply current, and also the Q factor. Okay. So what do we have here? So at ano na yung mga given natin? So given RL, which is 100 millihenry, and a resistance R is equal to 800 ohms. Okay, V equal to 12 volts. Okay, and an FR. Okay, okay, an FR is equal to 5 kilohertz. So this is how we determine the resonant frequency, but we have already the resonant frequency, so kaya pinapahanap na rito ay yung capacitance. So by manipulating this or this equation, we could say that the capacitance C is equal to 1 over L multiplied by 2 pi FR square plus R square over L square. Okay? Dahil kompleto naman yung ating mga ingredients, we have resonant frequency of 5 kilohertz, we have an R of 800 ohms, and then we have an inductance of 100 millihenry. So we could just simply substitute all the values to determine the capacitance C. Okay? And that will now give us 9.515 nanofarad. Okay? And then to determine the dynamic resistance, so RD now is equal to L over CR. Okay? Okay, meron tayong L, meron tayong C, nakuha natin kanina, and then we also have the R. Okay? So L is 100 times 10 to the negative 3 Henry, and then we have a capacitance of 9.515 nanofarad. Okay, and then we have resistance of 800 ohms. So the dynamic resistance now would be equal to 13.14 kilohertz. Sorry, kilo ohms. Okay. And then for the supply current at resonance, so that is IR, so we could now have it as V over the dynamic resistance RD. So we have V of 12. And then our dynamic resistance is 13.14 kilo ohms. So that is 13.14 times 10 to the 3. And therefore, the supply current at resonance would be equal to 0.913 milliamp, or this is 913 microampere. Okay. And for the Q factor, let's use this 2 pi FRL, or this is XL over R. Okay? So whether we use XL or we use XC, okay, parehas lang yun din yung ating pupuntahan. So the Q factor will be equal to 3.93. Okay? So, and that will be all for tonight. Okay? So it's almost 8:30 and that will now be for series and parallel resonance. Okay? So any question? Any question? Any question so far? Nandiyan pa ba kayo?
Wala
Opo,
po,
sir.
sir.
Wala naman.
Wala na
naman,
kayo?
sir.
Hindi po, sir. Wala pong tanong.
Walang tanong. Kala ko wala na kayo. Sorry. Anyway, so that will be all for our series and parallel resonance. Okay? Or simply resonance. Okay? So let me just get your attendance. Okay? Okay. So please visit our visit our Canvas for the assignments on AC power and resonance. Okay? Then tomorrow, please start doing experiment number, saan ba tayo tumigil? Sa 4, no? So please do experiment number 5 tomorrow. So magkakaroon tayo ng asynchronous tomorrow. Okay?
Okay, sir. Noted.
Yes. Thank you. Let me just get your attendance for tonight. Nasaan na yung aking yung video nung ating lecture last time, nakita niyo na, nasa Canvas na. Nalagay ko na, di ba? Nakita niyo na ba?
Yes po, sir.
So later on, lalagay ko din doon yung ating lecture. Okay? Attendance. Where is the attendance?